Part 6. In this, we are going to see about CAN architecture and working. That is the working of CAN protocol as well as the architecture which basically we deal with. So before that, we have just given the pictorial representation of the CAN protocol. So these are all just a CAN bus. So in this way, the CAN has been implemented in the real car. So again, we thought to just give you a clarity that CAN bus is nothing but a two piece of wire, that is twisted pair wire. So this is from Mercedes-Benz car. So these are all the CAN cables. Yeah. So for these cables have been working with the set of protocols. So that is what CAN protocol that we are going to see. So mostly this CAN protocol is a theoretical concept, so there is no much derivations or formulas. So this is the ISO 11898 architecture. So after this you can see the architecture for the low speed as well as the high speed CAN. So before that, let's see this. Here we have the application layer. So we'll start with this application layer. So this in this layer we can have the UDS protocol, OBD protocol, so that we can have the CAN protocol to make communicate with this UDS, so by means of UDS protocol. Then we have a data link layer, physical layer. So these are all the two layers that CAN really works on. So what it works, let's see from this way. So this is the CAN bus line. From this CAN bus line, it is the data has been, there is this CAN bus line is nothing but this wire, these two pieces of wire. So these wires have been represented as a CAN bus line. So whatever the information has been gathered, it will just receive as in the CAN transceiver. So CAN transceiver is nothing but the transmitter plus receiver. So it will receive, then it will send to the embedded CAN controller. So that is here we will program how the stuff wants to be. Then here DSP or microcontroller, that is a common microcontroller. So these CAN embedded microcontroller can be accommodated with the help of these two layers, physical layer and data link layer. Physical layer is mainly for an interface, that is however we are taking the CAN data from the CAN bus, then it will make through the medium as well as signaling the data. Then once the data has been successfully transmitted, so it will goes to the medium access, that is a target device, then a logic link control. So what are the logic has been done, or in a simple way, so what needs to be done, that's what has been given in this control unit. So again once this process has been done, so it will just do the vice versa, so it will send through the transmitter. So here we have the two CAN, that is high speed CAN and low speed CAN. So this is 11898 architecture, and here we have the 11892 network, that is high speed CAN. So this is what the architecture of the high speed CAN. So here we have the resistor, that is termination of two ends. Here we have the CAN node, that is not terminated, and as it is terminated at the end, so it is not required to terminate here. So this is also one of the interview question as well as the concept that you have to understand. So the question may be like, if these two ends of these terminals has been terminated with the 120 ohm resistor, and is this required to terminate here? The answer is no. So any of the two ends is enough, so we don't want to terminate here. Then so we have the subnets, the CAN node 1 can consider as a CAN node 2, and this is a CAN node 3. So this is how the high speed CAN architecture is. I will see the low speed CAN. So here in high speed CAN we have only the few nodes, the two very high priority nodes is connected in this way. But if we consider this low speed CAN, we have n number of nodes that needs, as you remember, in a modern cars we may have 90 numbers of ECU. So it's not possible and not advisable to connect all the ECU in the high speed CAN, hence we are going for the low speed CAN. So we have a number of low speed CAN here and there. So for this low speed CAN has the ISO as 11898-3 network. this is 2, and this is 3. So in this way it will be like the topology is a network star topology. So here we'll see the signaling also of the high speed CAN and low speed scan. So the high speed CAN is signaling is like, see here, as it is high speed, there will be the potential difference between the basically what is high speed signaling and what is low speed signaling. Before this, what is high speed CAN and low speed CAN? Simple. High speed can should be used for the critical issues such as airbags or braking or powertrain module engine control. So for these we can use the high speed CAN. So these high speed, what literally the high speed CAN and low speed CAN does, so it's so simple. See here, this signaling we can see the high in the high speed CAN, the voltage difference between the CAN high and CAN low is very less. See, only this much. So it may be some 1.2 1.3 volt, so that the data transmission will occur so soon. But whereas in low speed signaling, see the voltage differences, the voltage difference will be more. So there is a main difference of this high speed CAN and low speed CAN. So here we have both are 0 to 5 volt, and here we have 0 to 5 volt, but the signaling, the data transmission will always be late, because the low speed CAN is not required that much fast. So also it is not advisable to use all as a high speed CAN, as it is cost effective, as well as the you know the application is not advised to use. It's not simply waste. Say for example, if you consider some data has to be transmit and to be noted in 100 millisecond per second, 100 millisecond. But if you want to, if the data has been, the protocol has been transmitting it in a 10 millisecond, then there is no use of acquiring those signals. So that is the purpose that we are not going for a high speed and low speed configuration. Okay, so this is a simple concept of this is a simple architecture. Then high speed low speed, fine. Then here we have the overall understanding of the CAN controller. As we said, this is a two wires that we have seen in the first slide. So once this one sends to the transceiver, after this, so this is the overall it's outer diagram. But here we can see the bus line. The bus line is nothing but here we have this as a bus line, the two bus, then CAN transceiver, then again controller. This is the overall microcontroller. So this complete one is called CAN node. So that is what you should understand. So we have the architecture you should understand. So this is what the complete CAN node. In that CAN node we have a CAN transmitter, CAN receiver, and CAN controller. Because many has been misunderstand that CAN controller means they are considering this as a CAN controller. No, CAN controller is a part of the controller or a chip where the program has been done. This then we have a CAN transmitter, we have a CAN receiver. So which in turn we have the CAN this CAN transmitter and receiver plays this physical layer, that is interface layer. Then CAN controller is a data link layer. This is ISO 118981. This is 2 and 3. So this you have to be understand. So this complete stuff is called CAN node. So this is the overall understanding of the CAN controller as well as the CAN node. So you can expect these kind of questions, that if you want to go in depth, say for example this CAN controller, see the basic question is in which OSI layer the CAN controller will be. So your answer will be two layers, right? But it's not correct. So the CAN controller will be in data link layer only. So the CAN node will be in two layers, that is the physical layer and the data link layer, but CAN controller is only in data link layer. The same way, CAN transmitter and receiver in the physical layer only, that has been splitted as a ISO standard, but it is in the only layer. So this is what the basic understanding you should have, and this is what overall called CAN node. So we have different, see here we have CAN bus, here we have CAN transmitter as well as receiver, that is CAN transceiver. Here we have a CAN controller. So this overall is called CAN node. So that's what the overall understanding is. In our next tutorial we'll see about the CAN protocol broadcast logic with the more example and interesting stuff. So just keep on watch and try to get in watch it again and again, as it is a theoretical concept that you have to look into more to get to make it understandable.